Hi, welcome to Assignment 7. In this assignment, we'll be looking at balancing equations and the types of equations, and predicting the products of an equation. The reason we have to balance an equation is due to the law of conservation of mass. And this law tells us that mass can neither be created nor destroyed in a chemical reaction. So that means the same elements and the same number of elements have to be on the reactant side as on the product side. A few parts to a chemical reaction is the numbers in front of the chemical reaction. We call these the coefficients. The arrow between we read as yields. The symbols after the reaction are the states of matter. There are 4 different states of matter that we commonly see in a chemical reaction. The first being a gas. The next one is a solid. The third one is aqueous, AQ. And what aqueous means is that that particular chemical is dissolved in water. It is soluble and it is able to dissolve in water. The last one is liquid. The difference between aqueous and liquid is that for an aqueous solution, it is dissolved in water. For a liquid solution, that means it is a liquid at room temperature. We're going to see this mostly with water, bromine, and mercury. Mercury and bromine are the 2 elements that are liquid at room temperature. The rest of the elements are either gases or solids. You can get the state of matter for any of the elements off of most periodic tables. Now, whether a compound is aqueous or it's going to be a solid, you would use a solubility chart, and we do that later in chemistry too. In addition, we have numbers, small numbers at the end of the compounds or after the elements. We've already been figuring these out as we figured out formulas. These are your subscripts. When you put the compound together, you're going to put the subscripts in then. You never, ever, ever can change the subscripts. When you're balancing a chemical reaction, once you set the subscripts from writing the formula, all you can do to balance is add coefficients to the front of the number. Coefficients have to be in a whole number form, and they can be added to make the equation balance. On the left side of the equation, we call those the reactants. These are the reactants are the elements or the compounds that go into the reaction. If it's a compound, the bonds are going to break, and then those elements are going to be reformed into the products. And the products are totally new and totally different from the elements. So if we look at the equation, H2O2 produces H2O. Remember, hydrogen and oxygen are diatomic elements. And the diatomic elements are the elements that are so reactive that they're never going to be by themselves. So if you write a single element, you're always going to have to ask yourself, is it a diatomic? The diatomic elements are hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, and iodine. If you have a diatomic element, you're going to put a 2 as the subscript. So how does this equation violate the law of conservation of mass? Well, in this equation above, there's only one oxygen on the product side and there's 2 on the reactant side. So if we wrote this equation, oxygen is destroyed in the process, and the law of conservation of mass tells us that chemical reactions, mass or matter cannot be destroyed or created. And so the way we would do this is we would look at our equation, and I'm going to have to get 2 oxygens on the product side. So I would put a coefficient of 2 in front of H2O. Now we have 2 more hydrogens, or a total of 4 hydrogens. So that would violate the law because hydrogen would be created. And so to take care of this, we'd have to put a 2 as a coefficient in front of hydrogen. Remember, the coefficient is the integer in front of an element or compound, which indicates the number of moles that are present in that compound. The subscript is the integer to the lower right of the element, which indicates the number of atoms present. So for H2, there's 2 atoms present. And by putting the coefficient of 2, that means we have 2 H2 molecules, or a total of 4 atoms of hydrogen, and 2 atoms of oxygen on the reactant side. If I count up, I would have on the product side, I have 2 molecules of water, which means I have 4 atoms of hydrogen and 2 atoms of oxygen. The species is the individual reactants or products that form in a chemical reaction, and we may only use coefficients to balance an equation. Never change the subscripts in a formula. Once you get the subscripts done, then you have to keep them as they are. So in this equation, the coefficients tell us that there are 2 silver, 1 sulfur. If there's no number as a coefficient, then that means it's the number 1, and 1 silver sulfide. The subscripts tell us that we have 1 silver, 1 sulfur, and then 2 silvers in silver sulfide, and 1 sulfur. So if we count it up, the 2 in front of the silver means that we have 2 silver atoms. The 1 in front of the sulfur means we have 1 sulfur. And then on the product side, we have 2 silvers and 1 sulfur. And our equation would balance out. Some tips to balancing chemical equations. One good rule to start with while you're learning how to balance chemical reactions is to draw a line between the reactants and the products and make a list of every element that's in the compound. If I have, on the reactant side, I have 2 hydrogens and 2 oxygens. On the product side, I have 2 hydrogens but 1 oxygen. So I'm going to look at water, and I'm going to say I need 2 more oxygens. So I'm going to put a 2 as a coefficient. But that's going to change the number of hydrogens to 4. So I would have to come back over to the hydrogens and make that 4. After you get used to balancing equations, you don't need to worry about drawing the out the reactants and the products. Some reactions you'll be able to just look at and figure out what you're going to be adding as coefficients. Now, in the second reaction, we have a polyatomic over here with OH. Keep your polyatomics together whenever you can. If you have hydrogen and hydroxide on one side of the reaction and you have water on the other, think about water as a hydrogen and a hydroxide. This is your two hydrogens and your one oxygen. Keeping your polyatomics together is going to make balancing the equation much easier. So in this reaction, I have sodium, hydrogen, and hydroxide. On the reactant side, I have one sodium, one hydrogen, and one hydroxide. On the product side, I have one sodium, two hydrogens, and one hydroxide. So I've got to come over because I need two hydrogens for my products to balance out with my reactants. So I'm going to put a 2 in front of the water. That's going to give me two hydrogens, but it also gives me two hydroxides. So now I've got to come over and balance out hydroxide. And I can do that by putting a coefficient of 2 in front of sodium hydroxide, which gives me my two hydroxides, but it also gives me two sodiums, which I'll have to come and balance out on the reactant side by putting a 2 in front of sodium. Now, everything is balanced. I have the same atoms and number of atoms on the reactant side as on the product side. For this reaction, this is called a combustion reaction. And in a combustion reaction, it's always best to balance carbon, then to balance hydrogen, then you would want to count up your oxygens on the product side, and then if you end up with an even number, you can simply divide that by 2. Now, this reaction, the combustion reaction, is a little bit backwards because we're actually looking at the equation for cellular respiration here. And what happens in cellular respiration is plants take in carbon dioxide through the pores in their leaves, and they absorb water through their root system, and they're able to produce glucose and give oxygen off as a byproduct through the same pores in their leaves. So if we look at this, normally we would say our products are always going to be carbon dioxide and water for a combustion reaction. We have carbon, we have hydrogen, and we have oxygen. On the reactant side, I have one carbon, 4 hydrogens, and 1 oxygen. I'm sorry, I have 2 hydrogens and 3 oxygens. The side that has carbon dioxide and water is always going to come out to be 1, 2, 3 because those two compounds are always going to be the same. On the product side for this, I have 6 carbons, 12 hydrogens, and I have 8 oxygens. So I'm going to balance out carbon. I'm going to do that by putting a 6 in front of CO2, which is going to give me 6 carbons. I'm going to wait a minute before I count the number of oxygens, and I'm going to balance out hydrogen. I have 12 on the product side, so I need to put a 6 in front of H2O. And that gives me my 12 hydrogens. Now I can count up the number of oxygens on the CO2 and H2O side, whether it's the reactants or the products. Most of the time, your CO2 and your H2O will be on the product side. So that's going to give me 6 times 2, or 12, plus 6 times 1, or 6, which gives me 18 oxygens on this side. I have oxygen in both of my species on the product side. So what I need to do next is subtract out the number of oxygens. So 18 minus 6 is going to give me 12. And then I have O2 here by itself, and I can use that O2 to balance out. So there's 2 per molecule. So if I divide 12 by 2, that gives me a 6. And I can come over here and put 6. And now everything is balanced out. Now remember, I said you want to try to keep polyatomics as a group instead of breaking them down into their single elements. Since we have sulfate on the reactant and the product side, and we have hydroxide on the reactant and the product side, we can do that for this reaction. What I would do is I would balance it out by saying aluminum has 2, sulfate is 3, calcium is 1, and hydroxide is 2. On the product side, there's going to be 1 aluminum, 1 sulfate, 1 calcium, and 3 hydroxides. The best way to balance an equation is to look at the higher oxidation number elements first, or polyatomics, which would be aluminum in this case. Aluminum is out of balance, so I need 2 on the product side, so I'm going to put a coefficient of 2. But that also gives me 2 times 3, or 6 hydroxides. Now, I need to balance out the sulfate. I need 3 on the product side. So I'm going to put a coefficient of 3 in front of calcium sulfate, which now gives me 3 calciums and 3 sulfates. Now I can come over and balance out calcium and hydroxide because they're in the same compound. I can put a 3 as a coefficient in front of calcium hydroxide, giving me 3 and 6. And now everything would be balanced in the reaction. Here are some practice problems for you to work. Work them, stop the video, work them, and then come back to the video and check your answers. Don't worry about number 6 because there was a typo on that problem and it wasn't going to work out. Here are the answers to the practice problems. Check them over and make sure that yours are correct. A couple of things that I want to point out is you always need to make sure that your coefficients are in simplest form. 4H2 plus 2O2 yields 4H2O. That gives us 8 hydrogen on both sides and 4 oxygen. And while it does balance, it is incorrect because 4, 2, and 4 are not in simplest form. And so the correct answer would be 2, 1, and 2. Also, if you look at number 8, you'll notice that it was already balanced. And this can be the case sometimes. An equation can be balanced with all 1s as the coefficient. Next, we will talk about the types of chemical reactions and how we can predict the products of a chemical reaction. The first type is a single replacement reaction. This is a reaction where one species replaces another, one species on one side, and it's combined on the other. So, for instance, their basic equation for a single replacement reaction is going to be A plus BC yields AC plus B. You're going to start with a single element and a compound, and you're going to end with a compound and a single element. Now, for the single replacement reactions, you have to use a chart, and you have one in your notes, and it's called the activity series. And the way this chart works is, in the first example, I have silver plus gold 3 chloride. I'm going to look at the single element. The single element is a metal. So I'm going to find the metal in the compound. This is going to be gold. Next, I'm going to come down and look at the activity series of metals, and I'm going to see which one is higher on the chart. Is gold higher than silver, or is silver higher than gold? Well, silver is third from the bottom and gold is the last one. So silver is higher than gold. And so since silver, the single element, is higher on the activity series, then there is a reaction that's going to occur, and the reaction is going to produce silver chloride. Silver has a +1 charge, chlorine has a -1. So it would be AgCl plus the gold. And then I would have to balance it out by putting a 3 here and a coefficient of 3 in front of the silver. If the reaction had been the other way, in other words, we had gold plus silver chloride, I would look, both are metals, silver and gold are my metals. Now, silver is higher. The element in the compound is higher. And because of this, we would see that we would have no reaction. Gold is not going to replace silver because gold is less reactive than silver would be. Here's some practice problems that are single replacement reactions. Calcium chloride plus lithium. If I look at the single element, lithium is a metal, so I'm going to find the metal in the compound. This is going to be calcium. I'm going to look at the chart, and I'm going to see that lithium is higher than calcium. And so I'm going to have a reaction that occurs, and my products are going to be lithium chloride with a +1 and a -1. So it would be LiCl plus calcium. And now I have to balance. I'm going to put a 2 in front of lithium chloride and a 2 in front of lithium. In the next problem, lithium carbonate plus aluminum. I'm going to look, aluminum's a metal, so I'm going to find the metal. Lithium is in the compound, and lithium is the higher element on the activity series. So that means that we're going to have no reaction. You can also have single replacement reactions where the nonmetal is replaced. And so fluorine is a nonmetal, and it's the individual element. So I'm going to look for the nonmetal in the compound. If I look at this chart for nonmetals, iodine is all the way at the bottom and fluorine is all the way at the top. And so calcium with a +2 charge is going to be with fluorine as a product. And so my product would be CaF2 plus I. Now, remember about your diatomics. When you're writing a single element, you've got to check in your mind and see, is it a diatomic? And iodine is indeed a diatomic. And so I would put a subscript of 2 there, and that would make this reaction balanced. The second type of reaction is a double replacement reaction. And a double replacement reaction is where 2 compounds are going to react, and then they're going to switch partners and form 2 new compounds. So in other words, you would have a general reaction of AB plus CD yields AD plus BC. You can kind of think about it as the 2 nonmetals switch places in the compounds. So if I have a compound like lead 2 nitrate and potassium iodide, I don't have to look anywhere and see if this reaction will occur. If it's double replacement, it's going to occur. I only have to figure out which elements are going to be together in the products. When I write the products, I'm always going to put the metal first and then the nonmetal. So lead would be with iodine in the products. So lead is lead 2, so it has a +2 charge. Iodine has a -1. So the product would be PbI2 plus potassium would now be with nitrate. Potassium has a +1. Nitrate has a -1. And so the product would be KNO3. And now I have to balance it. I need to balance out iodine. So that's going to be a 2 there. And I'm going to balance out nitrate by putting a 2 in front of the potassium nitrate. And now I have 1 lead, 2 nitrates, 2 potassiums, and 2 iodines on each side. I could also have the reaction calcium chloride plus sodium nitrate. Calcium and sodium are switching places. So in the products, calcium with a +2 charge would be with nitrate with a -1 charge. So the product would be CaNO3 2. And then sodium with a +1 would be with chlorine with a -1. And so it would be NaCl. Now I would have to balance. I'm going to see that that nitrate and chlorine are out of balance. So I can come over here and put a 2 in front of sodium chloride to balance out my chlorine. And then I can come and put a 2 in front of sodium nitrate, which will balance out my sodium and my nitrate. Another example would be aluminum oxide plus potassium chloride. So my products, aluminum would be with chlorine at the end. Aluminum with a +3 charge, chlorine with a -1 charge, and when I'd cross it over, I would get AlCl3. My other product would be potassium oxide. Potassium is +1, oxygen is -2, so this would be K2O. Now I have to balance. I'm going to balance out my highest oxidation number, which is going to be aluminum. So I'm going to do that by putting a 2 in front of aluminum chloride. Then I have to balance out chlorine by putting a 3 in front of potassium chloride. But I can see that's not going to work because I already have 6 chlorines on the product side. So sometimes balancing equations is a trial and error thing. If one thing doesn't work, then look and see if you can figure something else out that'll work. And so I would have to put a 3 to balance out oxygen, which is going to give me 6 potassiums, 6 chlorines, and so I would need a 6 in front of KCl. In the third type of reaction, we have a synthesis reaction. A synthesis reaction is where we're going to take more than one reactant and we're going to create one product. So, for instance, A plus B is going to yield AB. If I have aluminum plus oxygen, they're going to combine to form aluminum oxide. Aluminum has a +3 charge, oxygen has a -2, so your product is going to be Al2O3. And then I'm going to have to balance it, and I'm going to balance it by putting, I've got a 3-2 situation. So in a 3-2 situation, the best thing to do is try to make 6. So I'm going to do that by putting a 2 in front of aluminum oxide. Then I have to put a 3 in front of the oxygen molecule. I'm going to have 4 aluminums on the product side. So I have to come back and put a coefficient of 4 in front of the aluminum on the reactant side. I could also have something like potassium and chlorine is going to yield potassium chloride. So potassium is +1, chlorine is -1. So the product would be KCl. But since chlorine is a diatomic, I've got to balance it out now because I have 2 chlorines on the reactant side and only 1 on the product side. I'm going to do that by putting a 2 in front of potassium chloride. And then I'm going to have to come and put a 2 in front of potassium. Now, the fourth type of reaction is a decomposition reaction. In a decomposition reaction, we're going to take one reactant and we're going to create more than one product because this type of reaction is a breaking down of the compound. So, if I have something like sodium phosphate, sodium phosphide, it's going to break down into sodium and phosphorus. I need to look at the 2 individual elements that I'm writing, ask myself, are either one of them diatomic? And they're not. So I can just go on to balancing and put a 3. If I had calcium chloride, it's going to break down into calcium and chlorine. Chlorine is diatomic, so I have to put a 2, and that's going to mean that it's balanced out as it is. There are a few special synthesis and decomposition reactions that don't just break apart into single elements or form a compound the way you would think they would. These are when we have a polyatomic that's involved. So if we have a carbonate's going to decompose to produce carbon dioxide and a metal oxide. Similarly, if we have carbon dioxide and a metal oxide, it's going to form a metal carbonate. If I have a hydroxide, it's going to break apart into water and metal oxide. So for instance, if I have magnesium hydroxide, it breaks apart into water and magnesium oxide. Similarly, if I have water and a metal oxide, it's going to form metal hydroxide. If I have a metal chlorate, then it's going to break apart and form a metal chloride and oxygen. Or if I have the metal chloride and oxygen, it's going to form metal chlorate. The last type of reaction is a combustion reaction. A combustion reaction happens when we burn something. If you see the words that, for instance, CH4 is burned, then that would mean you would add O2 to the reactant side. So your equation would be CH4 plus O2. On the other side, you're always going to have carbon dioxide and water. So this would produce CO2 plus H2O. Now, these are a little trickier to balance, and so having a method to balance them makes it a little easier. The first thing you want to do is balance your carbons, then balance out your hydrogens. Then you want to count the number of oxygens on the carbon dioxide and water side. If that's an even number, you would simply divide that number by 2 and put it as the coefficient for O2. If it's an odd number, you would still divide it by 2, put that coefficient in front of O2, but then remember, we can't have a decimal number as a coefficient, so we would have to multiply all the coefficients by 2. For instance, in C3H8 plus O2, we have 3 carbons, we have 8 hydrogens, and 2 oxygens. On the carbon dioxide and water side, we're always going to have 1 carbon, 2 hydrogens, and 3 oxygens. So I'm going to balance out carbon by putting a coefficient of 3 in front of carbon. I'm not going to count up the oxygens just yet. I'm going to come back and balance my hydrogen by putting a 4 in front of water. That gives me my 8 hydrogens. Now I'm going to come and count up my oxygens on the carbon dioxide and water side. I would have 3 times 2, or 6, plus 4 times 1, or 4, which would give me a total of 10 oxygens. Divide that by 2, which is going to give me 5. And I would put a 5 in front of my O2, and my equation would be balanced. If I had C3H6 plus O2, it's going to still produce carbon dioxide and water. And in this case, I have 3 carbons, 6 hydrogens, and 2 oxygens. On the other side, again, I have 1 carbon, 2 hydrogens, and 3 oxygens. So I'm going to balance out my carbon by putting a 3 in front of carbon dioxide. That's going to give me the 3 carbons. To balance out hydrogen, I need to put a 3 in front of water. That gives me my 6 hydrogens. Now I'm going to count up my oxygen on the carbon dioxide and water side. 3 times 2 is 6, plus 3 times 1 is 3, and that's going to give me 9. Now, my answer here is not an even number, so I'm going to divide by 2, and that would give me 4.5. If I put a 4.5 in front of O2, I can't leave it there because I have a decimal number. So what I'm going to do is I'm going to come and I'm going to multiply each coefficient by 2. And that's going to make my 4.5 9, which will be a whole number. And so 2 times 1 is 2. 2 times 4.5 is 9. 2 times 3 is 6. And 2 times 3 is 6. For a combustion reaction, you can also have a CHO compound and O2 on one side. You would still have CO2 and H2O on the other side. So to balance these reactions, you want to balance carbon, then balance hydrogen, then count the number of oxygens on the CO2 and H2O side. You would then subtract the number of oxygens in the CHO compound from the number of oxygens on the CO2 and H2O side. Divide that answer by 2 and place it in front of O2. So in this case, I would have 5 carbons, 10 hydrogens, and 2 oxygens on my reactant side. And then on the CO2 and H2O side, I have 1 carbon, 2 hydrogens, and 3 oxygens. I'm going to balance out carbon by putting a 5 in front of carbon dioxide. And I'm going to balance out hydrogen by putting a 5 in front of H2O. Now that my carbon and hydrogen are balanced, I can count the number of oxygens on the CO2 and H2O side. So I would have 5 times 2, which is 10, plus 5 times 1, which is 5, or a total of 15 oxygens. What I need to do now is look at my CHO compound and subtract the number of oxygens here. There's 5, so that's going to give me 10 more that I have to account for on my reactant side. I'm going to divide 10 by 2. It's going to give me 5, and I am going to put a 5 in front of my O2. Here are some practice problems to predict reaction products. Go ahead and stop the video, work these problems, and then come back to the video and check your answers. Be sure you tell what kind of reaction it is, what the products are, and balance. Here are the answers to these practice problems. Now go on ahead and work the practice problems that have the answers, and then work the problems to the lesson problems to turn in. Have a good week. Bye.